A routine underground scan beneath Baalbek in 2023 began as a structural check, but quickly revealed something far deeper. Hidden beneath the ancient platform in Lebanon, sensors detected massive chambers and precise formations, extending far below known levels, suggesting the visible ruins are only a fraction of what actually exists. The scan that shouldn't exist. A deep-ground sonar survey began beneath the ancient platform at Baalbek during late 2023, initially focused on structural stability beneath the Temple of Jupiter. Engineers were mapping load distribution to understand how the massive stones had remained intact for centuries. Early readings appeared routine, but as scans extended deeper, instruments began detecting large hollow spaces beneath the foundation. These were not shallow gaps or minor fractures. The data showed extended voids reaching depths beyond 30 meters, far below previously studied layers. Now this is where it becomes important. The shapes of these voids were not irregular. Sonar imaging revealed straight lines, defined edges, and repeated symmetry across multiple scan points. In natural geology, underground cavities tend to form unevenly due to erosion or seismic shifts. That distinction is important. What appeared beneath the site showed consistent geometry, suggesting intentional carving or construction rather than natural formation. Teams working on site in Lebanon paused the initial survey to verify results, repeating scans across adjacent sections. The findings remained consistent. Additional readings confirmed that these spaces were connected, forming what appeared to be a network rather than isolated pockets. The structure beneath the platform was not random. It followed a pattern. As the data was reviewed, the scope of the project shifted. What started as a structural assessment turned into a controlled investigation. Access to certain areas was limited, while further analysis was conducted, and additional scanning equipment was brought in to map the full extent of the underground formations. The focus moved from preservation to understanding what had been built beneath one of the most well-known ancient sites in the region. The platform that already defied logic. The platform at Baalbek had already raised questions long before any modern scanning began. It is home to some of the largest cut stones ever used in construction, including the famous trilithon blocks, each weighing between 800 tons and over 1,000 tons. These stones were placed with precision, forming part of the foundation beneath what later became the Roman Temple of Jupiter. Even with modern machinery, moving and positioning stones of that size remains a major engineering challenge. Now this is where it becomes important. The Romans, who expanded the site during the 1st century, are widely credited with the visible structures above ground. However, the foundation they built upon appears older than their occupation. That distinction is important. The size, weight, and placement of the base stones suggest a construction phase that predates Roman engineering methods. Studies conducted in 2014 and later reinforced by site analysis showed that the lower foundation layers do not match typical Roman building techniques. The precision of the stone cuts and the scale of the blocks indicate a level of planning and capability that is not clearly documented in known historical records of the region. In nearby areas of Heliopolis, smaller structures follow more conventional patterns, making the contrast even more noticeable. The foundation at Baalbek stands apart, both in scale and execution. The presence of these massive stones beneath the Roman temple shifts the focus away from who built what is visible toward identifying who constructed the base that made the entire structure possible. What the sonar actually detected. As the survey expanded beneath Baalbek, deeper scans conducted in early 2024 began revealing a far more complex internal structure than initially expected. The sonar did not just detect empty space, it mapped multiple layers of chambers positioned beneath the known foundation. These chambers were arranged at different depths, forming stacked sections that extended well below previous excavation limits. Some cavities reach beyond 40 meters, placing them far beneath any documented construction layer associated with the visible temple. Now this is where it becomes important. The internal layout showed straight corridors connecting these chambers, with angles and alignments that repeated across multiple scan lines. This matters because natural cave systems rarely produce consistent geometry over such a wide area. The density readings confirm that the walls surrounding these voids were made of carved stone, not eroded rock. That distinction is important. It indicates deliberate excavation or construction, rather than natural formation over time. In one section beneath Heliopolis, imaging revealed a central corridor running parallel to the platform above, with smaller chambers branching off at regular intervals. This pattern suggests a planned internal design rather than isolated spaces. The structure appears interconnected, forming a network that extends across the base of the site. As teams reviewed the full scan data, attention shifted toward understanding the purpose of this underground system. The presence of layered chambers, connected pathways, and consistent geometry suggests that the space was used in a structured way, rather than being a byproduct of construction above. The findings point toward a concealed complex beneath the platform, one that had remained undetected despite centuries of study. The depth that breaks expectations. Further analysis of the sonar data revealed that these structures extend far below the known archaeological layers associated with Roman Empire construction. Excavations in the region had previously focused on surface and near-surface remains, typically linked to Roman and Phoenician activity. However, the newly detected formations lie well beneath those layers, indicating a much earlier phase of development. Now, this is where it becomes important. The depth at which these chambers are located suggests that they were constructed before the existing foundation was put in place. This matters because it introduces the possibility of multiple construction phases, with the lower levels predating all visible structures above. The scale and depth of these formations are not consistent with known building practices from the Roman period. Data reviewed during 2023 indicated that some of the deepest sections extend beyond any previously recorded excavation depth in the area. That distinction is important. It means these structures were never part of the documented archaeological record, and their existence was not anticipated based on earlier studies. In regions surrounding Lebanon, no known civilization has been credited with constructing underground systems at this scale and depth using carved stone. The engineering required to create such spaces would have involved advanced planning, resource coordination, and technical capability beyond what is currently attributed to early societies in the region. The focus has now shifted toward identifying when these structures were built and which culture may have been responsible, as their presence suggests a timeline for Baalbek that extends further back than previously accepted. The engineering problem no one can solve. The construction at Baalbek has long been considered one of the most difficult engineering problems in ancient architecture, but recent findings have made that problem even more complex. The massive stones used in the platform, especially the trilithon blocks, weigh between 800 tons and over 1,000 tons, far exceeding the lifting capacity of most modern cranes. These stones were not only moved, but placed with precision, forming a stable base that has remained intact for centuries. Now, this is where it becomes important. The presence of newly detected underground chambers suggests that the engineering effort extended far below the visible structure. This matters because building beneath such massive weight requires advanced planning. Any underground space would need to support enormous pressure without collapsing. That distinction is important. It indicates that whoever constructed these layers understood load distribution and structural balance at a level not typically associated with ancient construction methods. Despite extensive studies, no clear evidence has been found of ramps, tools, or transport systems capable of moving stones of this scale in the region. In studies conducted around 2014, researchers examined quarry sites near Lebanon where similar stones were cut, yet no complete system explaining their transport and placement was identified. The cuts themselves show smooth surfaces and precise angles, suggesting advanced knowledge of geometry and stone shaping. The focus has now shifted toward understanding how these techniques were applied not only above ground, but also in the construction of the deeper layers revealed by sonar. The hidden network beneath the site. As sonar mapping expanded beneath Baalbek, the detected chambers began to form a larger pattern rather than isolated spaces. Scans conducted through 2023 and into 2024 revealed that many of these cavities are connected by narrow passages, forming a network that extends beneath the entire platform. This was not expected from earlier studies. which assumed any underground features would be limited or irregular. Now this is where it becomes important. The connections between chambers suggest a unified system rather than separate construction phases. This matters because some of the pathways appear to align vertically, indicating the presence of shafts linking deeper levels to the surface. In areas near Heliopolis, data shows vertical channels that could have been used for movement, ventilation, or structural support. That distinction is important. It suggests functionality beyond simple storage or empty space. Additional patterns observed in the scans show certain corridors following lines that could correspond to water flow, raising the possibility of early hydraulic systems integrated into the structure. Other sections, however, do not align with any known utility pattern and appear to be purely structural or ceremonial in design. The combination of functional and non-functional spaces points toward a complex system with multiple purposes. The mapping process is still ongoing, but the current data indicates that the underground layout extends beyond the immediate foundation. This suggests that Baalbek may be part of a larger subsurface network, one that has remained hidden beneath the site despite centuries of observation and study. Why parts of the site are restricted? Excavation activity beneath Baalbek has become increasingly limited, especially following the deeper scans conducted in 2023. The primary reason given by local authorities relates to structural risk. The massive stone platform above creates pressure conditions that make underground exploration difficult and potentially unstable. Even small disturbances in lower layers could affect the integrity of the entire site. Now this is where it becomes important. The restrictions are not only about safety, but also about control over how the site is studied and accessed. This matters because the region itself, located in Lebanon, has faced ongoing political and economic instability, making long-term research projects difficult to maintain. International teams often require extended access and consistent conditions, both of which have been limited in recent years. That distinction is important. It means the pace and scope of research are shaped not just by scientific factors, but by external conditions as well. At the same time, not all sonar data has been publicly released. Portions of the deeper scan results remain restricted, with only selected findings shared through official channels. Archaeologists working on site have reported incomplete access to certain zones, particularly those identified as deeper or more complex. In areas near Heliopolis, entry to specific sections has been delayed or denied, while further assessments are conducted. The combination of structural concerns, restricted data, and limited access creates a controlled research environment. The site remains active, but the full extent of what lies beneath is not yet fully available for independent study. Theories that are starting to emerge. As more data is reviewed from scans conducted through 2024, researchers have begun forming different interpretations about the origins of the structures beneath Baalbek. One of the primary theories suggests that the foundation may predate the Roman period entirely, possibly extending back to earlier, less documented phases of construction. This is based on the depth and complexity of the underground chambers, which do not align with known Roman engineering patterns. Now this is where it becomes important. Some researchers are proposing that the site may have been built over an even older structure, one that served a different purpose before later civilizations expanded it. This matters because it introduces the possibility of multiple layers of occupation, each adding to the site without fully replacing what existed before. That distinction is important. It shifts the focus from a single civilization to a sequence of developments over time. Comparisons have also been drawn to other megalithic sites, where large stone construction and unexplained engineering techniques appear without clear documentation. In regions outside Lebanon, similar patterns have been observed, though not at the same scale or depth. The underground chambers at Baalbek add another layer to this comparison, particularly due to their organized layout and connection to the surface structure. Different interpretations continue to develop as more data becomes available, but no single explanation currently accounts for both the visible platform and the deeper formations beneath it. The global pattern that connects everything. Across multiple regions, similar construction patterns have been identified in places far beyond Baalbek. including sites in Peru, Egypt, and Turkey. These locations are known for massive stone blocks, precise cutting, and construction methods that are still difficult to fully explain. Now, this is where it becomes important. The similarities are not limited to size or scale, but extend to the level of precision and the apparent absence of transitional building techniques that would normally show how such methods developed over time. This matters because in sites like those studied between 2010 and 2020, researchers documented stone joints so precise that even modern tools struggle to replicate the fit. In some cases, underground chambers and hidden passageways were also discovered beneath these structures, suggesting that what is visible above ground represents only part of the construction. That distinction is important. It points toward a recurring pattern where surface architecture is supported by deeper, often concealed systems. In regions near Cusco, similar underground layouts have been observed, while in parts of Anatolia, layered construction suggests multiple phases of development across long time periods. These parallels indicate that Baalbek may not be an isolated case. Instead, it appears connected to a broader pattern of construction techniques and planning approaches that appear across different civilizations. The alignment of these features across distant locations suggests the possibility of shared knowledge, whether through direct contact or parallel development, forming a pattern that extends beyond a single region or time period. What this discovery really means. The understanding of Baalbek as a purely Roman structure has shifted significantly following the SONAR findings analyzed through 2024. The visible temple complex, long attributed to Roman engineering, now appears to be built upon a much older and more complex foundation. Now, this is where it becomes important. The deeper structures revealed beneath the surface suggest that earlier construction phases existed long before the Roman expansion of the site. This matters because the underground formations indicate that large portions of the site remain unexplored. Some of these areas appear sealed or inaccessible, with no direct entry points identified during current surveys. That distinction is important. It means that the known structure represents only a fraction of the full site, with additional layers still hidden below. Ongoing studies since 2023 have focused on mapping these deeper sections, but limitations in access and technology have slowed progress. In surrounding areas of Lebanon, similar subsurface anomalies have been noted, suggesting that the site may extend beyond its current boundaries. The findings are prompting a reassessment of historical timelines, particularly regarding when large-scale stone construction first appeared in the region. The combination of surface and subsurface evidence is gradually building a more complex picture of the site's development, one that extends beyond previously accepted historical frameworks. The deeper the scans go beneath Baalbek, the clearer it becomes that the visible structure is only part of a much larger system. What has been mapped so far in 2024 shows layers of construction that extend far beyond what was previously studied. These findings are not replacing known history. They are adding to it, revealing complexity that was never fully documented. The underground chambers, aligned corridors, and structural depth suggest planning that spans multiple phases of development. In Lebanon, research teams are now focusing on connecting surface architecture with what lies below, trying to understand how these layers relate to each other. This matters because it shifts attention from what is visible to what remains hidden. With each new scan, more of the site's internal structure is being outlined, but large sections remain inaccessible. The limitations of current technology and restricted access mean that much of the underground system is still unmapped. What is already confirmed is enough to change the direction of research. The focus is no longer just on who built Baalbek, but on how much of it still remains beneath the surface, waiting to be fully understood.